Good morning. Welcome you all to a new session of AZ classes. Today we are going to start our 12th standard mathematics classes. Before starting our first lesson, let us get familiar with the whole chapters that we have to learn. NCERT divided the entire syllabus of plus 2 of second year mathematics into 2 volumes of books. The first volume containing 6 chapters, and they are relations and functions, inverse trigonometric functions, matrices, determinants, continuity and differentiability, and applications of derivatives. And the second volume contains 7 chapters. They are integrals, application of integrals, differential equations, vector algebra, 3-dimensional geometry, linear programming, and probability. Now we are going to start our first lesson, and its beautiful name is relations and functions. As you know, we learned this chapter in detail in our previous year. What we learned in the second chapter of 11th standard is the first chapter of 12th standard. Okay, let us start. Chapter number 1, relations and functions. This chapter contains 3 subtopics. First one is relations, second one is functions, and the third one is binary operations. The basics of these 2 topics are familiar with us. To get a starting, let us begin with the concepts that we have learned in our 11th standard mathematics. Okay, let us start from relations. Before saying what is a relation, let us consider an example. Let A is equal to set 1, 2 and B is equal to set 3. Do you know what is A cross B? What is the cross product of A and B? Yes, A cross B is the set of all ordered pairs such that first components belongs to A and second component belongs to B. That is, A cross B contains the elements 1, 3 and 2, 3. Let me write what is A cross B. A cross B is equal to 1, 3, 2, 3. How many elements are there in A cross B? 2 elements. All of you know that the number of subsets of a set equal to 2 raised to m, where m is equal to number of that set. Here A cross B contains 2 elements. Then how many subsets are there for A cross B? That is very clear. 2 raised to 2 equal to 4. A cross B has 4 subsets. Let me list that subsets. First subset contain only one element. What is that? Set 1, 3. Okay, set 1, 3 is the first subset. What is the second subset of A cross B? That is the set 2, 3. These 2 subsets are the subsets containing only one element. Is there any more subsets containing only one element? No. Now let us write the subset containing 2 elements. Which is that? That is set 1, 3, 2, 3. Okay. Is there any other subsets containing 2 elements more? No. Then what is the last subset? There are total 4 subsets, and which is the last subset? Last subset is the subset containing no element. What we call that subset? that is 5 empty sets. Okay, it contains no elements, 0 elements. Okay, these are the 4 subsets of A cross B. Clear? If A is equal to set 1, 2 and B is equal to set 3, the 4 subsets of A cross B are listed here. Now let us discuss what is a relation. Okay, what is the meaning of relation? It is a connection. It is a connection of the elements of set A to the elements of set B. Let me say a connection, that is, element of B is greater than, okay, 1 greater than that of element of A. Element of B is 1 greater than or 2 greater than. First we say element of B is 2 greater than that is element of A. Then which is that relation, which is that connection? 1, 3. As you know, 3 is the number greater than 2 of that 1. Okay, 1, 3 is the first relation. Order pair 1, 3 is the first relation from A to B. What is the relation? The element in B is greater than 2 of the element in A. Okay, then 1, 3 is the first relation. What is the second relation? Element in B is greater than 1 as that in A, that is set to 3. Then let me say another relation from A to B, that is element in B is greater than that of element in A. What is that relation? Element in B is 3 and elements in A are 1 and 2. Therefore every ordered pair 1, 3 and 2, 3 satisfies the given condition. Therefore the third relation is 1, 3, 2, 3. And another relation is element in B is less than that of element in A. Is there any elements containing that relation? No, there is no such element, because the only one element in B is 3 and that element is greater than that of elements in A. Therefore there is no element in the relation in which element in B is less than that of element in A. Therefore the fourth relation is 5. Okay, now I mentioned 4 relations from A to B. If you say any other relation from A to B like this, you get any one of these 4 sets. Okay, or in short we can say that a relation from A to B is a subset of A cross B. Okay, it's a subset of A cross B. That is, there are in total 4 relations from A to B, and they are, first relation, let me denote it as R1, is set 1, 3, and second relation R2, that is set 1, 2, 3, and third relation R3, and it is set 1, 3, 2, 3, and the fourth relation is the relation containing no element, that is 5. These are the 4 relations from A to B. Okay, or in basically, what is the definition of a relation? A relation from A to B is a subset of A cross B. Okay, whenever we speak about a relation in mathematics, we should keep in mind that a relation from A to B is a subset of A cross B. This is the only one formal definition of a relation from A to B. Say with me, relation is a subset of A cross B. Clear? Now, there are 3 terms which are closely related to every relation. Very important terms. That is, one domain, second one range, and the third one codomain of a relation. All these things are learned in 11th standard. So I don't go to details of these sessions, just to mention here. Okay, listen. Let R be a relation from A to B. R be a relation from A to B. Then what is the domain of this relation? What is a relation? Relation is is a subset of A cross B, and A cross B contain ordered pairs. Ordered pairs has 2 components, first component and second components. Then what is the domain? Domain is the set of all first components in a relation. Set of all first components in a relation. What is range? Set of all second components in a relation. What is codomain? Codomain is very simple. If the relation is R, if the relation R is from A to B, then B is called the codomain of the relation. Okay, let me write these things in the set builder form. Domain of R equal to set of all x such that xy belongs to R. xy is an ordered pair and x is its first component. Set of all first components in a relation is called domain. Set of all first components or x are called domain of R. Then what will be the definition of range of R? Say alone, set of all y such that xy belongs to R. Set of all y, what is y? Second component. Set of all second components in this ordered pairs in a relation are called range of R. Then what is codomain? To say about codomain, don't bother about the relation, just to mention the second set. Okay, codomain of R equals second set is B. If the relation from A to B, then B is the second set and codomain of R is B. Okay, let us see an example. A is equals to 1, 2, 3, 4 and B is equals to 4, 5, 6, 7, 8 and R be a relation from A to B. Clear? Then can you and the definition of R is like this. R is equals to 1, 5, 3, 6, 4, 8. Then can you say what is the domain, range and codomain of this relation? Definitely. What is the domain? Set of all first components, that is equal to set 1, 3, 4. What is the range? Set of all second components. Range of R is equal to set 5, 6, 8. And what is the codomain? To say the codomain, don't look at there is no need to look at the relation, but it is enough to check from where to where the relation is defined. The relation R is defined from A to B, therefore second set is B and the codomain of R is equal to B. Okay, let us see whether our answers are correct. Okay, this is the correct answer. Okay, domain is equal to 1, 3, 4 correct and range is equal to 5, 6, 8 correct and codomain equal to B, that is also correct. Okay, now let us explain some more results relating to relations. Okay, see, let number of A is equal to M and number of B is equal to N. How many relations can be defined from A to B if number of relation equal to M and number of A is equal to M and number of B is equal to N? Okay, then what is a relation? A relation is a subset of A cross B. Okay, to find the number of relation, we want to realize what is number of A cross B. What is number of A cross B? Number of A equal to M and number of B equal to N. What is number of A cross B? That is nothing but Mn. Okay, A cross B contains Mn elements. Okay, what is a relation? Relation is a subset of A cross B. That is the all subsets of A cross B, all subsets of a set containing Mn elements. Okay, then what is the number of subsets of a set containing Mn elements? That is nothing but 2 raised to Mn. Okay, therefore number of relation from A to B is equal to 2 raised to Mn. Number of relation from A to B equal to 2 raised to number of A into number of B. Clear? Now listen. A cross B. A cross B is a set. You know, every non-empty set has at least 2 subsets. Which are they? One is empty set. Second one is A cross B. Okay, these 2 sets are always exist. These 2 subsets always exist if A cross B is non-empty. These 2 subsets are called trivial subsets. Okay, you may hear that every set has 2 subsets, that is null set and full set are subsets of every set. Null set and full set are subsets of every set. Now listen, phi is a subset of A cross B. A subset of A cross B is called a relation from A to B. Hence, phi is a relation from A to B. How many elements are there in phi? 0 elements. No elements. Okay, there is no element in the relation phi. Since phi is a relation, we call it as empty relation. Phi is called empty relation. Okay, now A cross B is also a subset of A cross B. Every subset of A cross B is a relation from A to B. Therefore, A cross B is a relation from A to B, and A cross B is the largest relation from A to B. It means that A cross B contains the maximum number of elements in the relation. Okay, therefore A cross B is called the biggest relation. What is the term we use for biggest in the sense of set? That is universal. Okay, A cross B is called the universal relation. Okay, phi is called empty relation and A cross B is called universal relation. Let's write as these facts as our notes. First note is the number of relation from A to B is equal to 2 raised to mn, where m is equal to number of A and n is equal to number of B. We mentioned earlier, so there is no need of any description. Okay, second point is that is the two sets need to define a relation? Is A and B is compulsory to define a relation? No, we can define a relation from A to A itself. What we say, a relation from A to A? A relation from A to A is called a relation on A. A relation from A to A, if the relation is defined from A to A, is called a relation on A. And third point is that what is the name of A cross A? A cross B or A cross A is called universal relation, we mentioned earlier, and the relation phi is called what? Empty relation. Okay, A cross B is called universal relation, phi is called the empty relation, and the relation from A to A is called a relation on A, and number of relation equal to 2 raised to number of A into number of B. These are some important facts relating to relation. Okay, now let us start our 12th standard topics. Here we want to learn types of relations, very important one. Okay, types of relation. To understand which are the types of relation, let us go through simple examples. Okay, consider the example. Let S equal set 1 2 3 and let R is equal set 1 1 2 2 3 3 1 3 2 3. R is a relation on A. Why? R is a subset of A cross A. Every element in R belongs to first component, second component belongs to A. Therefore, R is a relation on A, or R is a relation from A to A. Observe this relation carefully. What can you observe from here? 1 is an element of A, 1 is related to 1 here. 2 is an element of A, 2 is related to 2 here. 3 is an element of A, 3 is related to 3 here. It means that every element in A related to itself. Every element in A related to itself. In other words, we can say every element reflects itself by R. Every element reflects itself by R. These types of relations are called reflexive relation. What is the name of this relation? Reflexive relation. A natural question may arise. Here 1 3 is there, 2 3 is there, 1 is not related to 1 here. No problem. 1 3 and 2 3 may or may not contain this relation. It is not, don't bother about this 1 3 and 2 3. If I delete this 2 3, this relation is again reflexive. If delete I 1 3, then also this relation is reflexive. But if we erase this 3 3 from this relation become non-reflexive. Okay, therefore the compulsory elements are in R to be reflexive is 1 1 1 1 2 2 and 3 3. Don't bother about 1 3 2 3 3 2 etc. These three elements are compulsory to make it reflexive. Clear? Then let us take another example. S equals to 1 2 3 4 5 and consider this relation. Is this relation reflexive? 1 is here, 1 1 is here, 2 is here, 2 2, 3 3 3, 4 4 4, 5 5 5. Every element in A related to itself, therefore this relation is reflexive. I just write 4 5 here, don't bother about it. It may or may not be in this relation, etc. There may be more elements, no problem. But these 5 elements are compulsory. 1 1 2 2 3 3 4 4 5 5 are compulsory to make it reflexive. Okay, what about this one? If S equals to A B C D E F, how many elements are here? 6 elements. Okay, to make a reflexive relation on this set, it must contain at least 6 elements, which are the A, B, C, D, E, F. 6 elements must be there. Okay, here 3 elements are in this set, then 3 elements must be in the relation R to make it reflexive. 5 elements are here, 5 elements must be here to make it reflexive, and here 6 elements are there, and to make a reflexive relation on this set, that relation must contain at least 6 elements, and they are A, B, B, C, C, D, D, E, F, F. Suppose if a set contains 100 elements, then how many elements must be in a reflexive relation? 100 elements. If the relation contains 99 elements, we can definitely say the relation is not reflexive. Suppose I am going to define a reflexive relation on the set of students in your class. Suppose your class contains 50 students, then how many elements must be there? How many elements must be there? 50 elements must be there. Some of your names are Ramu, Arun, Siddharth, etc. Then that reflexive relation must contain Ramu, Ramu, Arun, Arun, Siddharth, Siddharth, etc. Then only that relation is reflexive. Clear? Then let us write the formal definition of a reflexive relation. A relation R on a set capital A is reflexive if, tell me, what when we say that a relation is reflexive, if this suppose this element is small a and this is capital A, if A belongs to A, small a belongs to A, then ordered pair AA must be in R. Okay, when we say that a relation is reflexive, AA belongs to R for all A belongs to A. If A belongs to capital A, then that element must be related to itself for every element A. This is the formal definition of a reflexive relation. Then say with me, what is a reflexive relation? A relation R on A is said to be reflexive if AA belongs to R for every A in A. Once more, AA belongs to R for every A in A. Now we have learned what is a reflexive relation. Okay, now let us write some notes. First note is this one. The relation A cross A, is it reflexive? A cross A is reflexive? Sure. Why? A cross A contains all the elements, therefore it contains all ordered pairs AA for every A in A. Therefore the universal relation A cross A is always reflexive. What about the relation empty relation phi? Is it reflexive? No, because phi contains no elements, 0 elements, hence there is no AA. Okay, there is no AA. Therefore the relation phi is not reflexive. And what is the minimum number of elements? What is the smallest reflexive relation on a set A? Which is the smallest reflexive relation on a set A? Suppose A is equals to 1, 2, 3. What is the smallest reflexive relation? If the set is 1, 2, 3, then the smallest reflexive relation is 1, 1, 2, 2, 3, 3. Okay, this is the smallest reflexive relation on set A. This relation is called identity relation. Okay, then which is the smallest reflexive relation on a set? That is identity relation. Okay, some of you may not familiar with the identity relation. For that, write an example. Let S equals to 1, 2, 3, then R equals to 1, 1, 2, 2, 3, 3 is called identity relation. Okay, identity relation must contain only 3 elements. Okay, only 3 elements, every element related to itself, every element keep its identity. That is why we call it as identity relation. Then identity relation is the smallest reflexive relation on A. Okay, then what is the fourth note? The minimum number of elements in a reflexive relation on a set A is equal to, very simple, you can say, what is the minimum number of elements in a reflexive relation? What is the smallest relation? That is identity relation. Identity relation contains number of elements. Okay, therefore minimum number of elements in a reflexive relation on set A is equal to number of A. Clear? Then let us learn what is next type of relation. Okay, listen. Another a very simple example. S equals set 1, 2, 3 and R equals set 1, 2, 2, 1, 1, 1. Okay, keenly observe this relation. This is a relation on A. What is the peculiarity of this relation? Here 1, 2 is here. When I just reverse this element, what we get? 2, 1. Okay, then 1, 2 is here. The reversed element 2, 1 is also here. When 2, 1 is reversed, we get 1, 2. 2, 1 is here. Reversed element 1, 2 is here. Okay, 1, 1. 1, 1. When we reverse, we get 1, 1 itself. Therefore, the reversed element of 1, 1 is here. In short, we can say that if AB belongs to R, then BA also belongs to R. Ordered pair AB belongs to R, then ordered pair BA also belongs to R. Such types of relations are called symmetric relation. Such types of relations are called what? Symmetric. That is our second types of relation. Okay. To make a relation symmetric, it is important that whenever AB belongs to R, BA also belongs to R. We discuss about BA only when AB belongs to R. Suppose I delete this 1, 1. Then what about this relation? That relation is again symmetric. Okay. Suppose I delete this 2, 1. Is this relation symmetric? No. What is the reason? 1, 2 is here. It is reversed element is not here. If I delete this 1, 2, is that relation symmetric? No. Because 2, 1 is here, but its reversed element 1, 2 is not here. If I delete this both 1, 2 and 2, 1, at that time is that relation symmetric? Correct. Sure. What is the reason? Then at that time the only one element in R is 1, 1 and the reversed element of 1, 1 is 1, 1 itself. Hence the relation is symmetric. Here let's just take another example. R is equals to 2, 3, 2, 2. Is this relation symmetric? No. What is the reason? 2, 3 is here, but its reversed element 3, 2 is not here. Okay, therefore this relation is not symmetric. Another example, S equal to set 1, 2, 3, 4, 5 and consider this relation on A. Is this relation symmetric? Let us check. 1, 1, reversed element 1, 1, no problem. 2, 2, no problem. 3, 3, no problem. 4, 4, 5, 5, no problem. What about 4, 5? 4, 5 is here. What is its reversed element? 5, 4. Is that element here? No. Therefore this relation is what? Not symmetric. No, because this relation symmetric? No. What is the reason? 5, 4 is not in R. 4, 5 is here, but 5, 4 is not in this relation. Therefore this relation is not symmetric. Then what is the formal definition of a symmetric relation? A relation R on a set A is said to be symmetric if AB belongs to R implies BA belongs to R. Okay, AB belongs to R implies BA belongs to R. Whenever AB belongs to R, then BA must belongs to R. If AB does not belongs to R, there is no question of BA. Okay, if AB belongs to R, BA must be in R. That is the definition of symmetric relation. Then say with me, definition of symmetric relation: AB belongs to R implies BA belongs to R. What was the definition of reflexive relation? AA belongs to R for every A in A. AA ordered pair AA belongs to R for every A in A. Then what is the definition of symmetric relation? That is AB belongs to R implies BA belongs to R. Okay, now let us write some notes. First one, the relation A cross A. Is it symmetric? Sure, because A cross A contains every element. So whenever I write an element AB in this relation, its reversed element BA also must be in the relation. Therefore A cross A is a symmetric relation. Then can you say a relation which is reflexive and symmetric at the same time? Definitely. What is that? A cross A. A cross A is a reflexive and symmetric relation. What about this relation phi? Is that relation symmetric? Okay, let us check. Can you find an ordered pair AB in phi such that AB belongs to R and BA does not belongs to R? No. What is the reason? Because there is no element in phi. It means that there is no element in phi, there is no element AB in phi such that AB belongs to phi and BA does not belongs to phi. It means that condition for symmetry is not satisfied. Therefore we don't bother about the conclusion. Trivially we say that the relation phi is symmetric. Okay, the relation phi is symmetric. We cannot find an ordered pair AB such that AB belongs to phi and BA does not belongs to phi. Therefore we say that phi is symmetric. Okay, then third one, what is the smallest symmetric relation on A? Smallest symmetric relation is very simple, that is phi, because phi contains no element. Smallest symmetric relation on A is equal to phi. Clear? Now we learned two things. First one is a reflexive relation, second one is symmetric relation. Okay, Now we are going to learn very important and very interesting relation, third one. For that, take an example. Let S equals set 1, 2, 3 and let R equals set 1, 2, 2, 3, 1, 3. Okay, note the color. 1, 3, 1, 3 are in red color, 2, 2 are in blue color. Okay, 1, 2 belongs to R, 2, 3 belongs to R, then 1, 3 belongs to R. 1, 2 belongs to R, 2, 3 belongs to R, then 1, 3 belongs to R. Clear? Okay, let us call 1 as A, 2 as B and 3 as C. Okay, then what we say? AB belongs to R, BC, ABB, AB belongs to R, BC belongs to R, then AC belongs to R. These types of relations are called a transitive relation. This is the third type of relation, transitive relation. AB belongs to R, BC belongs to R, then AC belongs to R. These types of relations are called transitive relation. Then when we say that a relation is transitive, for any two ordered pairs AB belongs to R, BC belongs to R, satisfying AB belongs to R, BC belongs to R, then AC must belongs to R. That types of relations are called transitive relation. Let us take an example from our daily life. Suppose my brother's name is Shaiju. Okay, and brother of Shaiju is Anwar. Okay, then what can you say? My name is okay, I am A and my brother Shaiju is B. Then again Shaiju, he is B, and Anwar, that is C. Okay, my brother is Shaiju, Shaiju's brother is Anwar. What can you say? My brother is Anwar. Okay, my brother is Shaiju, Shaiju's brother is Anwar. Then you can say that my brother is Anwar. Therefore the relation brother is a reflex or is transitive relation. Okay, the relation brother is a transitive relation. What about the relation father? My father is Shaiju and Shaiju's father is Anwar. Can you say my father is Anwar? No, I have not two fathers. Okay, my grandfather is Anwar, become Anwar. Okay, therefore the relation father is not transitive, the relation friend is not transitive, the relation mother is not transitive. Okay, the relation brother is a transitive relation. Okay, now let us consider another example. R equals 2, 3, 3, 2. Is this relation transitive? Check it. Is this relation transitive? 2, 3 belongs to R, 3, 2 belongs to R. AB belongs to R, BC belongs to R. What about AC 2, 2? Is it belongs to R? No. Therefore, this relation is not transitive. To make it transitive, we must write 2, 2 here. Not only 2, 2, but also we can write 3, 2. This 2, 3 to the right side of 3, 2, then become 3, 2, 2, 3. Then 3, 2, 2, 3 belongs to R, in this 3, 3 also belongs to R. So, to make this relations transitive, we must include 2, 2 and 3, 3 in this relation. Clear? Now this relation is not transitive. Then what about this relation R equals 2, 2? Is this relation transitive? Here AB is 2, 2 and BC is also 2, 2 and AC is again 2, 2. Then AB belongs to R, BC belongs to R, AC belongs to R. Every element is 2, 2, AB, BC, AC, etc. are 2, 2. Only one element is there. Therefore, this relation is transitive. Okay. Now, let us consider another example. Let S equals 1, 2, 3 and consider this relation 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 4, 5. Is this relation transitive? To check it, let us start from the first 1, 1. There is no element starting with 1 here. 2, 2. There is no element starting with 2 here. 3, 3. There is no element starting with 3 here. 4, 4. There is an element starting with 4 here. 4, 4, 4, 5. A, B, B, C belongs to R. What about AC? That is again 4, 5. Yes, 4, 5 is here. Okay, AB belongs to R, BC belongs to R, AC, that is again 4, 5. 4, 5 is here. Therefore, this relation, and consider one more element, that is 5, 5. There is no element starting with 5. There is only one ordered pair is this 4, 4 and 4, 5. Then its corresponding element is 4, 5. Since 4, 5 is here, the relation is what? Transitive. Okay, now consider another example, that is R is equal to 1, 2, 3, 5. What about this relation? Is this relation transitive? Tell me, is this relation transitive? Okay, if this relation will not become a transitive relation if you can find two ordered pairs A, B and B C such that A, B belongs to R, B, C belongs to R and A, C does not belongs to R. Here first ordered pair is 1, 2. There is no element starting with 2 here, and second ordered pair is 3, 5. There is no element starting with 5 here. There is no two ordered pairs A, B and B, C in this relation satisfying A, B belongs to R and B, C belongs to R. Okay, as I said earlier, here the condition is not okay, therefore there is don't bother about the conclusion. Eventually or trivially we can say this relation is transitive. Okay, we can say a relation is not transitive only when AB belongs to R and BC belongs to R. At that time AC does not belongs to R. Okay, clear? And the final example is this one: 1, 2 here, 2, 5 here, 1, 2, 2, 5. A, B, B, C belongs to R. What about AC? 1, 5. Is 1, 5 here? No. Can we adjust with 5, 1? No. 5, 1 and 1, 5 are different elements, distinct elements. Okay. If 1, 2 and 2, 5 here, we must have 1, 5 here to make it transitive. Here there is no 1, 5 and hence this relation is not transitive. I think all of you clearly understand these all examples. Okay, then what is the formal definition of a transitive relation? Tell me. If AB belongs to R, BC belongs to R implies AC belongs to R. Whenever AB and BC belongs to R, if these two elements are in relation, then AC must be in R. Clear? Now we have learned the third type of relation, that is transitive relation. Okay, now write some note. What about the relation A cross A? Is it transitive? Since A cross A contains all the elements of the relation, clearly the relation is transitive. Then can you give an example for a relation which is symmetric, reflexive and transitive? Of course. What is that? A cross A. A cross A relation which is reflexive, symmetric and transitive at the same time. What about the relation phi? Is it transitive or not? Okay, can you find any two ordered pairs in phi such that AB belongs to phi and BC belongs to phi such that AC does not belongs to phi? No, never. There is no such ordered pairs in phi because phi is empty relation. It contains no element. Therefore, trivially we can say that the relation phi is transitive. Then the relation phi is symmetric and transitive but not reflexive. Okay, relation phi is symmetric and transitive but not reflexive. And the smallest transitive relation, which is the smallest transitive relation? Phi is transitive, phi is the smallest relation. Therefore the smallest transitive relation in the set A is phi itself. Okay, now today we have discussed three types of relations: reflexive relation, symmetric relation and transitive relation. What is a reflexive relation? AA belongs to R for every A in A. And what is a symmetric relation? AB belongs to R implies BA belongs to R. And what is the transitive relation? Whenever AB, BC belongs to R, then AC must be in R. Okay, I think all enjoyed this class, and today now I am going to conclude today's session. Okay, the class, the detailed notes of today's class is available in our description link. You can access the notes using that link. Okay, if you like this class, you can share and subscribe my channel ESR classes. Okay, till we meet on next class. Goodbye.